Still congealing is a new discipline in its own right. Data science has for several years come under increased scrutiny for its links to a string of prominent public controversies, from racial bias in predictive policing to disinformation on social media platforms. With data science's growing power and heightened profile in today's world has come the imperative to equip the data scientists of the future with the robust education in the ethics of science and technology. As part of our data science education program, the Human Context and Ethics Program, or HCE, aims to equip students with structured ways of thinking about the human condition in a world of ubiquitous data and computing technologies. Our approach is grounded in perspectives from the humanities and the interpretive social sciences. We believe that understanding the historical and structural dynamics between humans and technologies is essential to prepare the next generation of technology leaders, policymakers, and citizens who will be designing the human technology futures we live in. But what does it mean to think about the human contexts and ethics of data and algorithms? What kinds of questions come under the scope of this inquiry? To begin to probe these questions, let's look at an example that has received significant public attention over the last decade: self-driving cars, or autonomous vehicles. A futuristic technology that is promised to improve city life, increase traffic safety, and relieve us from the everyday drudgery of driving long commutes, autonomous vehicles have captured the imagination of technologists and segments of the public alike. Although the ethics of autonomous machines has been a topic of speculation for decades, recent progress in machine learning and artificial intelligence has brought it new life and immediacy. Represented most notably by MIT's recent moral machine experiment, an existing philosophical framework long familiar to ethicists has quickly become the standard reference, the so-called trolley problem. The trolley problem frames ethical decisions in terms of binary choices between alternatives: swerve and kill one pedestrian or the driver, or continue straight and kill 5. These thought experiments are used to uncover the basic principles behind our moral intuitions. In the case of self-driving cars, they've become heuristics for what counts as ethics of autonomous vehicles, and blueprints for designing allegedly ethical machines. The trolley problem framework does have the pedagogical value of helping students recognize the complexity of problems posed by value pluralism and in exploring their own ethical intuitions. Excessive focus on issues as framed by the trolley problem, however, may obscure, rather than enlighten, some of the most pressing human contexts and ethics of autonomous vehicles. So how do we begin to probe the broader human contexts, that is, the world of autonomous vehicles? First, rather than simply focusing on the structure of the algorithm driving the car in making a series of ethical choices, we can reflect on its design process. To begin, we can ask, who decides how the algorithm decides? Who are the engineers who are building it? What are their backgrounds, their identities, and their positionalities in today's society? How diverse are the programmers and designers? What kind of company do they work for? With what kind of culture? What kind of agency do they have with regard to company CEOs or shareholders? How are the decisions shaped by the culture of Silicon Valley, or by market pressures? Who is included and excluded in decisions about how autonomous vehicles are introduced into the world? This is one facet of the question of power. Who decides how autonomous vehicles decide? Already the range of humans involved in the making of the autonomous vehicle has significantly expanded from the focus on the driver or the engineers. Other relevant stakeholders include everyone who must share the road with the cars, and those unnamed people whose data is collected to train the algorithms on which the cars run. When we start asking about stakeholders, our attention is immediately drawn to questions about their representation. Who is represented in these data sets? Will the algorithm recognize cyclists and persons in wheelchairs, or someone pushing a stroller, as readily as anyone else? And in which communities are these technologies being tested? Are some communities over-surveilled, causing other communities to be underrepresented in the dataset? Greater representation usually requires increased surveillance. Does more inclusive representation also require more invasive surveillance? And do the affected communities get the chance to participate in the collection of this data, or are they unknowingly subjected to it? Next, we can ask about the labor involved in collecting and labeling this data. Who drives the cars that collect the data? What are the technical devices and infrastructures that enable it? And what are their specific affordances? Are the data sets they create labeled by exploited crowdsourced workers laboring for less than minimum wage? And then, according to what kinds of criteria are these images classified? Who designed the classification systems used to label these data sets? And what kinds of institutions exist to audit the data for accuracy, reliability, and completeness? Of course, technologists and drivers are not the only actors who design these algorithms. The various features of the world, our institutions, norms, laws, and sociotechnical infrastructures, the entire background of the world, participate in shaping the ways the algorithm learns and behaves. Autonomous vehicles depend on an already existing infrastructure, from the roads, crosswalks, street signs, traffic lights, traffic laws, and traffic cameras, to the norms that govern the behavior of drivers, bicyclists, and pedestrians. For example, the interlocking features of the insurance industry and law in the United States condition the design decisions made by the engineers. As one study has argued, because damages awarded in an accident are calculated based on incomes lost, engineers may be incentivized to design algorithms that drive slower and safer and wealthier neighborhoods, while prioritizing speed and efficiency in lower income neighborhoods, thereby encoding harmful and dangerous biases into the algorithm. But the human context and ethics of autonomous vehicles doesn't start and stop with the algorithms. For we shouldn't simply investigate the algorithm or the autonomous vehicle as a fully independent entity, simply affected from the outside by a multitude of different actors, but as one emerging participant in a vast set of interlocking sociotechnical systems, a participant with the capacity to deeply reshape these systems. For here the question is not simply about how the car's algorithm decides and the external contexts that inform the decisionality of the algorithm, but about how autonomous vehicles fit into a world under construction. This means treating the development of autonomous vehicles as a project of world building. Proposals for introducing autonomous vehicles into urban environments often arrive bundled with assumptions about the development of new smart cities, as parts of an interconnected, sensate environment in which real-time surveillance and feedback systems would be embedded into the urban landscape. In such cases, we return to the question, whom does this data serve? Who controls it? Who manages the infrastructure of cities that ensures the viability of autonomous vehicles? And further, how are these infrastructures themselves reshaped by the introduction of autonomous vehicles? And how would their effects be distributed across different cities, different neighborhoods, different communities? In other words, how would they scale? And indeed, what changes at scale? How do we ensure that autonomous vehicles effectively coordinate their behavior when our streets become crowded with models produced by different companies? Do they require us to reimagine the physical construction of intersections and crosswalks, the laws concerning pedestrian rights, legal liability frameworks, regulative institutions and principles? All of these elements shape, and in turn are shaped by, the creation of new networks of autonomous vehicles. In other words, we must pay attention to how technologies and social forms co-produce one another. Further, what are the particular affordances of autonomous vehicles compared, say, to extended public transportation infrastructure and taxi services? How do they figure in the imaginaries by which we envision how humans and technology are supposed to collaborate together in the pursuit of the good life? And what are the alternatives? Who has the privilege to imagine this future and the power to realize it? As another example, autonomous vehicles reinforce a mode of transportation that is notoriously energy efficient and unsustainable. As we consider public investment in infrastructure, What forms and systems of transportation promise the most equitable and sustainable access to the public? And once again, what are the power structures that distribute opportunities to direct the development of these projects? Who decides whether or not to introduce autonomous vehicles into our urban landscapes in the first place? Finally, how do humans and algorithms interact with one another? How is their agency intertwined and redistributed through these complex systems? We can ask how autonomous vehicles would affect the way we ascribe responsibility and liability to specific actors when they fail. For example, studies have shown that humans in the loop and automated systems are regularly held responsible in one way or another for system failures over which they have little to no control. This has come to the attention of the public, most recently during the testing of autonomous vehicles. When a collision occurs, who is at fault? Surely not the algorithm. The passenger in what was formerly the driver's seat? The human driver of the other car? The engineering team who designed the algorithm? The crowdsourced workers who labeled the training data sets? The CEOs or shareholders of the company who built the car? The urban planners who designed the roads? Or perhaps the teenager who spray painted the stop sign? In short, how do we effectively, that is, collectively, justly, and humanely, design these complex sociotechnical systems such that those people with the least power are not unduly exposed to the risks of the system? These are not simple questions with simple answers. They require time, effort, collaboration, contestation, and political action, founded upon a holistic, integrated, and structured approach to thinking about the human context and ethics, about the world of data science. Effectively teaching HCE thus means more than teaching students philosophical frameworks or a handful of typical ethical dilemmas. It means more than developing professional codes of ethics or best practices. It means helping students recognize and make sense of the complexities of what we call the datafied world. A world suffused with and constantly remade by practices of ubiquitous data collection, widespread analytics, an emerging culture of algorithms, and autonomous machines. It is a world that is malleable, receptive site of our projects, but one which also pushes back on even our best intentioned designs. For these reasons, HCE means teaching data science students to conceive of the work they do as a form of world building. This entails cultivating our students' ability to reflect upon and situate their own scientific expertise, and to view it as a kind of social power, and to understand how it is co-produced together with the socio-technical systems they help design. The most pressing ethical questions of the datafied world can't be hacked, they can't be programmed away, they can't simply be solved by creating less biased algorithms that better optimize for previously neglected variables. They are social problems that require collective action together with technology. In order to build a more just and humane world, it is crucial that we work with our students to cultivate engaged and responsible citizens who are able to reflect on their expertise, to recognize its limits, and to use it to effectively and democratically collaborate with the general public. So what does this approach to pedagogy look like in practice? In the course of the autonomous vehicle example, we employed several social scientific concepts, such as power, agency, co-production, and socio-technical systems, to help us illustrate some of the ways of seeing that we aim to teach students in the HCE program. These are a few elements of what we call the HCE toolkit. These concepts, derived from science and technology studies, the history of science, and philosophy, equip students with generalizable lenses, structured ways of seeing, which they can apply to novel real-world situations once they are out of the classroom. Much like our prior discussion of autonomous vehicles, we introduce students to the toolkit by demonstrating how they help illuminate a series of key case studies. We teach these tools in a variety of classroom settings as part of a two-pronged, integrated, and dedicated approach to institutionalizing HCE at Berkeley. The dedicated track involves offering courses focused specifically on human contexts and ethics. All data science students at UC Berkeley are required to take one approved HCE course, such as Data 104, in order to complete the major. In the spring of 2021, we will begin to offer a new HCE course, Data 4AC, Data and Justice, a lower division course which will fulfill Berkeley's American Cultures requirement. Additionally, we collaborate with a student team to offer those undergraduates especially dedicated to human and social issues additional mentorship opportunities to grow their knowledge and skills. Student team members are also crucial collaborators in our integrated approach. On this track, we embed HCE concepts, perspectives, and tools into the technical data science curriculum. We create targeted course interventions composed of homeworks, lectures, and discussion sections. Each intervention is designed to probe how the technical concepts taught in the course operate in real-world settings by finding more socially relevant data sets, adding new questions to existing Jupyter Notebook homework assignments, and sometimes creating new notebooks from scratch. Each intervention employs a subset of the HCE toolkit to provide students with a common HCE vocabulary across the data science curriculum. Through this twinned approach, we work to make human context and ethics an inextricable part of what it means to do data science in today's world. And so in place of the familiar Venn diagram of data science, we represent the place of HCE in data science as one chamber in a four-chambered heart. All four chambers, computing, statistics, domain expertise, and HCE, must beat as one to ensure that a more humane, ethical, and just data science at Berkeley and in the world becomes a living reality.